does this task fit in CCSM? How does this task fit Common Core? Ideas? It's open-ended, somewhat. We haven't told them how to do it. We haven't given them any numbers to work with. How else?
They have to know what a square measurement is.
They do have to know something about square measurement. Is it visual? Common Core is highly visual. Anything you can make visual, do it. Anything you can have them figure out, do it. It is a graphic issue. I'm sorry. I apologize. If you want to try to create this on Word all by yourself, you go right ahead.
We struggle with that piece.
It can look beautiful until they even are printed, and then it's not square anymore. We would make sure the student task sheet was squares.
It's square on our computer.
That's like the answer on the calculator must be right. What is the relationship we're asking them about from 1 to 2? What are we asking them to examine? Not just how. Aren't we asking them to generalize conversion as opposed to this for this unit and that for that unit? Isn't generalizing a higher level of thinking? It also fits Common Core because in Common Core it will specifically say change measures from larger units to smaller units. Initially, not both ways. It's confusing. When you go from larger units to smaller units, what has to happen? You get more of them. That is a concept. It is not a procedure, and we need them to have that concept. It's a reasoning thing. It's not a numerical thing. That's what makes this such a good task for Common Core. It includes comparison, and they must make sense of the math. Another quick task. Compare the oranginess of juice made with 2 cans of orange juice and 3 cans of yellow mellow to 3 cans of orange juice and 5 cans of yellow mellow. Notice it says, be ready to explain your thinking. Give you a couple of minutes to play with that. From the orange juice. Yellow mellow has no orange. What kind of thinking does this problem address? What kind of thinking does this problem address? Proportional thinking. How good is the U.S. on proportional thinking? Yeah, pretty much. Yes. Because of the additional strategies that come out of that. Some students may look at this as part to part, some as part to whole, some as additive, some as multiplicative. It is amazing when you give kids time to wrestle with a problem like this. This is not your typical set up a proportion and solve question. This gets at the proportional thinking. And one of the resources that we have been using quite a bit lately talks about if you only teach solving proportions, you have missed a great deal of important mathematics. Which is why we like this problem. But more important, who's doing the work? The new vision of teaching with Common Core has the teachers working less and the students working more. There's a saying that whoever is doing the most talking is doing the most learning. Who's doing the most learning? Are students challenged to explain their thinking? And is that a good thing? Have you ever had a student say, "You know what I mean"? And what do you say? "Oh, of course." No. Can you give me more details? Can you tell me a little more? And then you ask another student, can you say what he just said in your own words? And then you ask a third student, do you agree or disagree with what was just said and why? You can only do that if you quit stopping at the answer. Can there be several valid strategies on the oranginess problem? But then the Phil Darrow comment, the correctness resides in the mathematical argument. And would you have already taught them about oranginess? All right, we're going to switch gears now. We're going to go to mental math, because mental math is going to become more important in Common Core. And it needs to become more important in Common Core. So we have a task for you. We're going to end, except for our conclusions, this will be our last task. We think we need to teach mental math strategies and practice them. These are examples. What are we getting at in the last one? Tens, smart groups. Our students don't all realize that we can rearrange numbers and get the same answer. So most of them might say 8 plus 11 is 19 plus 2 is...
They missed it, though. They first
Oh, yeah.
grabbed their calculator.
I forget. I forget. All right, I forget. Okay. But just focusing on a strategy and practicing it can make them better. We can't just assume they know how to do these strategies. We must teach them. So this is our last task before we close, and that is, if we asked you to develop your own mental strategy to subtract 58 from 216, we would then ask you to represent it 4 ways. I'm going to flash to the representation page, and we do have a handout for that. We want you to put it into a story context that would require that subtraction. We want you to demonstrate the strategy on the number line with arrows. We want you to draw a picture or model it with base 10 blocks. And finally, we want you to describe the strategy in words. That's different from a story context. We call this the elementary rule of 4. How many different learning styles are we looking at? How much reasoning are we looking at when we ask them to represent it multiple ways? And how often do we have them do that? So back to the task. I'm not going to give you a lot of time on this because we always run out of time.